Hey guys, back again, and I thought I'd do a series of videos running through the design and manufacture of a jib crane that I'm working on. Now, just a few dimensions. The column will be 4 meters in height. The jib length will be around 4.2 meters. Should have around 3.5 meters under hook, maybe close to around 3.3 meters under hook. It'll have a Demag 1,000 kilogram chain hoist. It'll have electric travel, which will be pretty cool. I was thinking about doing electric slew, but we're just going to be doing manual slew. I'll run into that a little bit later on. But yeah, it should be a pretty cool looking jib crane, I think, and very strong jib crane. And yeah, it should be pretty good. Now, this software, just those of you that are interested, is Autodesk Showcase. Mainly use this just for presentations and whatnot. So yeah, don't do too many simulations on it, but can do. I used to in the past, but yeah, mainly now it's just for some quick, walkthrough videos and your ray tracing pictures and all that sort of thing, just for presentation. So anyway, we'll get back onto the design software. I use Autodesk Inventor and go from there. Okay, guys, we're back here again on Autodesk Inventor, and we're in the stress analysis environment of the software. Now, you can see we've got a couple of arrows here pointing downwards. This one over here is our downwards force for our hoist. It's 1,000 kilograms downwards. This is just considering our hoist is 1,000 kilograms lifting capacity, and the one over here is just our gravity. Now, with jib cranes, we have a main constraint of length. Well, in my country, it's length divided by 300. Just check with the engineer on what your deflection is, but ours is length divided by 300. I've seen length divided by 100, 150. So just check with your engineer on that one. And as you can see here, this is what we're talking about. So this is the deflection, that line down to the beam. I've just run a stress test here, and we can show the displacement at maximum displacement at 12.08 millimeters. Therefore, I'm actually within that length divided by 300, but it's a base that I use to actually design the crane itself. So this column here, if you can imagine, if it was longer, or if our jib length extended out further, or if we increased hoist capacity, would all have negative effects on that displacement. It would increase the displacement or the deflection on that jib beam. So you obviously have to design your jib in accordance to the length divided by 300, but those factors are going to be what determine, the dimensions of your column, your beam, and whatnot, to be within that tolerance. So that's basically what I used. Initially, I had a much smaller column. This one here is a 460 millimeter diameter column in about 14 millimeters, and we've got a UB 410 for our main beam. So that's pretty much what I used to actually design the crane itself. And what you can actually see as well, I'll go over here into the beam. Just give me a second while it loads. And you can see the displacement for the beam is actually 4.58 millimeters. That's the displacement just there, or the deflection. So you can see the majority of the deflection is being done in the column. So we had 12 millimeters. So we're looking at, 6.5, 7 millimeters in deflection from the column. Therefore, the main factor is getting that a good structure, a good column, a good base, just so it minimizes deflection back onto the beam. You can see we're at a safety factor of around, there we go, 5.5. That's no problem. And then going back to the beam here, I'll just get out of our stress analysis. But another main thing as well is, because we're using manual slew, we're not using electric slew. If we can keep that deflection down, it makes it so much easier for the guys to actually move the crane itself. If we had more deflection, both in the column and the beam, if you've got 1,000 kilograms load sitting out here, it just makes it that much harder to actually maneuver the slew, the actual beam itself. So that's a big factor. So if you can keep your deflection down, not only that, it will also minimize stress on your footings and your concrete, which obviously is extremely important. So look, if initially I was looking at going electric slew, which would have been great, but it's obviously more expensive. But it's something that this crane is not going to be used, all day, every day. So it it wasn't really worth it for me, but being manual slew, I needed to keep that displacement down in order for the jib to actually slew nice and freely. So that was important. But yeah, this is basically the design of the crane. I'll pretty much run you through everything. Next step is CNC plasma cutting just some parts. We've got some 8 mil, some 12 mil, 16 mil, and some 20 mil plate for the base. So plenty of parts to cut. And yeah, I'll try and take you through all the steps of the build and take you on the journey. And yeah, if you've got any questions, just chuck them down in the comments below. I'll try and answer them. And yeah, it should be good. Cheers.